चैनल को लाइक करें और सब्सक्राइब करें ताकि आपको सभी इंपॉर्टेंट अपडेट्स टाइमली मिल सके। सब्सक्राइब द चैनल नाउ। Hello, good morning. So what we are going to do today is we are going to practice one of the lessons, that is work and energy. Welcome all. Yes, hi. Welcome. We'll begin shortly. Let's other students join and we'll start. Okay, so what we are going to do basically today is we are going to practice work and energy, one of the chapters, and in that we are going to have it's going to be like a quiz based practice. So it's not going to be like a traditional practice. We are going to have a quiz based practice. So what we are going to do is we are going to suppose, let's say, have a quiz based practice on this lesson, and in this what we are going to do is I will be showing you one question. It will have 4 options. So you will be given 1 minute to read the question and to give the answer. You can give the answers in the chat box. Your chat box is on, so you can give so let's say give your answers to your questions, to the displayed questions by answering in the chat box. And 1 minute will be allotted for that. And in the next minute, I will be explaining that particular question, that answer. Fine. So allotted time is for you is 1 minute. That will be allotted time. That is your time. 1 minute will be given for your reading and solving. Reading plus solving, and the another 1 minute after that I will be devoting for, suppose let's say, explaining that particular problem. Explanation. I hope you are understanding the format of today. All you have to do is you have to read the question, find out the answer, and in that you have to give me the answer for what exactly? For, yes, in the chat box you have to write down the answer. So in the chat box you continuously interact what is your answer, and then you cross check that with my explanation. Fine. So let us begin our particular quiz of today. Let us start. So ready? Everybody is ready? Give me suppose let's say yes. Let me know in your chat box. Are you ready? Everybody is ready? Can we start? Okay. Fine. So kindly do one thing. Kindly keep your notebooks ready. Kindly keep your notebook ready for solving also. Notebook. Your notebook and suppose let's say your pen or pencil, whatever it is, for suppose solving part, because there are certain numericals also, so you will require your book to solve them. Yes, ready for the question now? Can we start our quiz? Ready? Write down in the chat box. Is everybody ready? Okay, so let us start. So our first question is this. I'll be giving you 1 minute time and you have to give me the answer in the chat box. You read the question, see the options, and after 1 minute we'll be discussing the solution. You can start giving your answers in the chat box. Once you complete your question, you can immediately start giving answers in the chat box. Yes, your time is complete. So the answer for this question is, let us just see. The answer for this question is C. Why exactly? The question is, when an object falls freely towards the earth. So suppose imagine a ball which is falling towards the ground, towards the earth. They are asking what is the total energy. What will happen to the total energy? Now they are not asking about potential energy, kinetic energy. As you know, whenever an object falls from a height, initially it has a lot of potential energy. Its potential energy would be the highest maximum, and its kinetic energy would be zero because it is not moving at all. But once it starts falling, when the ball reaches the ground, Potential energy in this case is 0, but kinetic energy will be maximum as it has the maximum velocity in that case. But what is total energy? They have asked us total energy. Now formula for total energy is total energy is equal to is nothing but mechanical energy, that is addition of kinetic energy plus potential energy. So addition as total energy is remaining same in both the cases, as total energy remains same for both the cases, so answer is going to be let's say remains constant. Total energy in this case is also potential energy, right? Okay, so that would be P, and total energy in this case is kinetic energy. So basically you can just say potential energy has completely converted to kinetic energy. That is what exactly we want to let's say infer from our question. So answer is remains constant. Chalo. Now this is your next question. You have 1 minute to give me the answer. Start writing down your answers in the chat box immediately. Once you read the question and the options, if you are ready with your answers, immediately start writing down, and constantly you can interact in the live chat, because so that in the I will be able to understand like who is giving like proper answers, like immediately one after the another. You can give answers multiple time also, so that there will be more probability of your answer being seen. You can give more, suppose let us say like you can answer again and again and again. Yes, in the comment section. That I just write it down in the live chat so that I can understand how many of, suppose let's say you are trying. Yes, just write it down in the comment section, chat box. Okay, your time is almost over. Okay. So let us discuss what is the answer for this question. The question is, which one of the following is not the unit of energy? They are asking who is not the unit of energy in this case. Like who is not the unit of the energy in this case? That is what they are asking basically. Okay. So one thing you have to understand is the unit which doesn't belong in this case is kilowatt. The main one of the unit it doesn't belong is kilowatt, because kilowatt is nothing but basically what? Kilowatt is exactly what? Yes, that is exactly, you need to understand that kilowatt is the unit of power. It is the unit of power. Now what about joule? Joule is the standard unit of energy, so there is no issue, right? This is the standard SI unit of energy. SI unit of energy. What about the second, suppose let's say the unit which is given in the option B, Newton meter. We can just change this. Newton is the unit for whom? Force, and meter is the unit for displacement. So can I just say actually what they are giving us is force into displacement, right? Okay, but as you know, force into displacement is work, but as you know, work is also called as energy. So basically this is the unit of energy, correct? Kilowatt hour is the suppose let us say commercial unit of energy. As you know, it is the commercial unit of energy. So basically this is also unit of energy itself. But there is a problem with kilowatt, right? Kilowatt is the unit of whom? Power. Kilowatt is the unit of power. That is the problem. Okay, so this is what you should remember. So answer is going to be C. They had asked who is not the unit, so answer is kilowatt. Chalo. Let us move to the next question. You have 1 minute to answer this question. And again, I am telling you, suppose let us say immediately once you give me the answer, you can start writing down your answers in the chat box. Just keep it, suppose let's say going. Constantly interact with me so that you won't feel bored in online classes. That is the main difference between offline classes and online classes. Whenever you are doing online classes, you make sure that you are constantly interacting with the teacher, not just with me, but everybody, so that you know, you will stay connected and you won't feel bored about these classes, right? Online classes. Give me the answer. Be fast. Write it down in the comment section. Which of the following energy changes involves frictional force? That is what they're asking. Okay, so your time is up. Let us just see what is the answer. The answer is B. Let us try to understand why B is the answer. Okay, let us just see why B is the answer. The question that was asked was, which of the following energy changes involves frictional force? Now, what is friction according to us? That means it is opposing force. But as you know, opposing, definitely the another definition for frictional force is opposing force. But opposing force also involves rubbing of two bodies. Opposing force, basically what it means, rubbing of two bodies. Two bodies are rubbing over each other, and that happens only if it is in motion. Correct? That happens only in motion. When two objects are moving over each other, only then, suppose let's say this is the object, this is another object, and if it is moving over each other, only then we are going to have that, suppose let us say opposing force, that frictional force. But due to this, they are in motion. But according to us, motion energy is which energy? Motion energy is kinetic energy, right? Motion energy is kinetic energy. So can I just say, now one thing which is really required for frictional force is kinetic energy, right? Okay, so kinetic energy, after suppose let's say frictional force comes into effect, it is converting into which energy? Heat. As you know, frictional force creates what? Heat energy. And where that is coming from? Kinetic energy is getting converted to heat energy. That is what you need to remember, that kinetic energy is getting converted to heat energy. Okay, so answer would be B. As they had asked about frictional force is due to motion, that is due to kinetic energy, and kinetic energy will convert to heat energy. Understood? So answer is B. Okay, so let us go for the next question now. Let us go for the next question. You have 1 minute to answer this question. Which one of the following statements about power stations is not true? They are saying not true. Okay, kindly answer accordingly. Not true. Once you are done with your answers, if you know the answers, so let's say whatever you feel like, and even if you doesn't know, like it doesn't matter like if you know the perfect answer or not, just try, because you might get it right, but you should never stop yourself from giving answers. It might be right, it might be wrong. If it is right, well and good, but if it is wrong, I am there to help you out, right? So you just have to interact. Keep your answers going, keep your answers coming. Like, which one of the following statements about power stations is not true? Power stations means where electricity is produced. So your time is like about to end for this question. Yes, your time is up. Let us just see what is the answer. The answer for this question is C. The answer for this question is C. Let us just say why. See, which one of the following statements about power stations is not true? They are saying which is not true. The first point is, hydroelectric power stations use water to drive turbines. We just have to see whether it is true. Hydroelectric power station use water to drive turbines. That is true. Turbines are basically the mechanical parts which move and which are connected to generators, which generally create electricity. So turbines, those are those moving parts through which we are moving that generator to create electricity, right? Generate electricity. So obviously, the water is definitely used to move the turbines. You must have seen this in suppose let's say Swades, like the movie of Shah Rukh Khan. So in that you must have seen the moving turbines. They have shown, yes, exactly, that is used. The water is used to move the turbines, and through that turbines are connected to generators, and generators would create electricity. In power station, turbines drive generators. Is it true that in a power station turbines drive generators? That is so true, because only through generators you can create electricity. Electricity from thermal power stations differ from the produced in hydroelectric power station. They are saying there are two types of power plants. One is thermal power plant and there is hydroelectric power plant. They are saying electricity from both the power plants differ. It doesn't differ. See, electricity is electricity. It doesn't matter how you are creating it. Whether you are generating that electricity from the hydroelectric power station or you are generating that from the thermal power station. It doesn't matter at all. What matters there is that electricity is produced. Electricity is electricity. It is pure form of energy. So you just have to understand that electricity, it doesn't matter, it's going to remain same for both the things, but they are saying it is different. So this is a wrong statement. This is a wrong statement, right? This is a correct statement. This is a wrong statement. In hydroelectric power stations and thermal power stations, alternators produce electricity. Alternators are nothing but the devices which convert mechanical energy into electrical energy. Always remember this. Alternators are what? Alternators are devices which convert mechanical energy to electrical energy. So kindly please remember that very important concept. Okay, in your book also you can write it up that what are alternators. So alternators are devices which convert mechanical energy to electrical energy. Please remember that. Chalo. Let us go for the next question. Now this is a numerical. So try to do this as fast as possible, and if you're not able to do, I will help you out. No issue. And once you are done, just write it down in the chat box. Live chat is already going. Just constantly interact with me, give me answers, and we will check whether you are correct or not. Just keep it going. Keep it going. You have 1 minute to solve this question. Okay, so the time is up. Let us just see what are your answers, whether they are correct or not. Let us just try to solve this, correct? Okay. So what they have given is, they have given us an electric motor has a load of zero point 0.2 kg, right? So that means mass has been given as 0.2 kg, correct? Okay. It moves through a vertical distance of 3 meters. So that means basically they have given S or H height. So basically it is 3 meters and time is given as 2 seconds. Okay, acceleration of a free fall is 10 meter per second square. So they are saying it is falling and acceleration due to gravity, that is G, is 10 meter per second square. So they are not asking us to take 9.8, they are asking us to take it 10. Now they are asking what is power. Now that is so simple. Power is nothing but, what is the formula? Power is equal to energy by time, correct? Energy by time. But in this case the object is falling right from a height, so the energy we are going to talk about, either we can take it kinetic energy or either we can take potential energy. But as they are talking about free fall and everything, so the energy in this case is potential energy. The energy in this case is potential energy. So you can replace that energy with potential energy, and the bottom part would be time. Now what is the formula for potential energy? It is mgh, correct? Potential energy can be represented by mgh and divided by time, that is t. Now put the values and you will get your answer. What is the value of m? M in our case is 0.2, correct? Okay, what is the value of G? That is 10. What is the value of H? That is 3. What is the value of T? That is 2. So 10 into 0.2, that is just 2. The answer is just 2. What about 3? This one. Okay, that you can just skip it there, or even you can multiply. See, 2 can be divided with this 2. The 0.2 and 2 10 has already been multiplied, so we have got 2 basically, and 2 into 3 divided by 2. So 2 and 2 is getting cancelled. So what is remaining? 3. And the unit for this case would be watt. So the answer is 3 watt. Are you understanding this? How this answer is coming up 3 watt? All you have to do is replace the energy with potential energy, put the formula of mgh, and whatever the values you have been given in the question, supplied with the question, just put them, those values, in our formula. That's it. You will get your answer. So this is normal calculation, that not that much hard. So answer is 3 watt. I hope everybody was able to give me the, so let's say, answer for this question. It was a very simple one. Okay, just write it down in the chat box. Has everybody been able to give me the answer? Okay, okay, fine. So let us go for the next one now. Next question. You'll be given 1 minute and you have to suppose, let's say, give me the answer for this. You have 1 minute to give me the answers. Just write it down in the comment section. Whatever your answer is, whatever you feel like. Read the question, read the options, and give me the answer in the chat box. That would be a great practice. Okay, I hope, so let's say your 40 seconds are almost up, like only 20 seconds are remaining. So I hope you are ready with your answers. Some students have started writing their answers. Write down in the comment section. That live chat is available. You can give me the answers there. Calculate on your notebook everything and give me the answer in the chat box. Okay, so your time is up. Let us just see what is going to be the answer. Now what they're asking is an object is falling freely from a height x. So what is the height? The height is x and the object is falling from a certain height. Okay, so let us just assume that this is the object and it is falling, right? And the height in this case is h or x. Okay, x, sorry. So the height in this case given is x. Now they are asking what will happen exactly at the half of the position, that is x by 2. Okay, so x by 2 is roughly this, right? This is exactly rough I can say, that is x by 2. So this must be x by 2 and this must also be x by 2. Correct? No. All they're asking is what is going to happen at this stage? What is going to happen at this stage? Obviously, the potential energy in this case is maximum. Kinetic energy at the top level is 0. At the bottom part, potential energy is 0, but kinetic energy is maximum. Now, what is going to happen at the middle stage? Obviously, it will be half. It will be kinetic energy will be half, and potential energy would also be half. That is the logic, because basically they are the object has come between, like at the central place, so they will have half of kinetic energy, half of potential energy. So answer is going to be C, half potential energy and half kinetic energy. Are you understanding? They had given the distance of x and they are asking us at middle distance what is going to happen. So we are going to get half potential energy and half kinetic energy. So simple. Let us move on to the next question. You have 1 minute to give me the answer for this question. The commercial unit of energy is. It says it's a very basic question. They're asking what's the commercial unit of energy. Start writing down your answers in the comment section, your chat box. Just give me the answers fast and fast and fast. Who will be the fastest one? Okay, some students have started giving the answers as soon as I have displayed the question. So some students are really studying. I like it. Good. So your time is almost up. Almost. So yes, so your time is up. Let me discuss now the answer. The question is the commercial unit of energy is. Let us just see. The commercial unit of energy is. That is what they're asking. Okay, so let us just see. So the answer for this question is going to be C, that is kilowatt hour. Watt is the unit of whom? Watt is the unit of whom? Power. Kilowatt is also the unit of power. Now what about the second and the third option? C. Watt hour is the unit of whom? Energy. And kilowatt hour is also the unit of energy. But you have to remember one thing, they had asked us commercial unit. Now out of these two, even though both of them are suppose let's say unit of energy, but the unit which is used for commercial purposes, that is kilowatt hour. So this is commercial unit. B and C both can be the options, but you have to understand that they are asking about commercial unit. They are not asking about any unit. There are so many units of energy, but they are asking for commercial, so C is the option. Commercial unit of energy. Okay, and I hope you remember that what is the relation between kWh and suppose let us say the joules. So one suppose let's say kilowatt hour, which is the unit of energy, is equals to 3.6 into 10 to the power 6 joules. Okay, this is one of the relations which you need to remember. You have 1 minute for this question. So let's say students, you have 1 minute for, suppose let's say for this question. Your time has already started. It is not that much hard. Try to calculate and give me the answer. If you are not able to give, I will be giving you the answer, but still, at least try. Write down your answers in the chat box. Okay, so let us just see what can be the answer. See, in this question, what they have given us is how much energy does a 100-watt electric bulb transfer in 1 minute? That is what they're asking. This is power. This is time. They're asking about energy. That is so simple. Power given here is 100 watt. Time given here is 1 minute. We need to convert this 1 minute into seconds, so that will be 60 seconds. Okay, and they're asking about energy. We can easily find out that. What is the formula for power? Formula for power is equal to energy by time, right? Energy by time. Put the value there. You need energy, correct? So energy in this case would be power into time, right? Energy, just suppose let's say transfer this t to the p side, so it will become power into time. Now put the values there. Value for p is 100, value for time is 60 seconds, so it will become 6 1, how many zeros? 1 2 and 3 zeros, 1 2 and 3, so that would be 6000 joules. Okay, so the final answer energy in this case is 6000 joules. Are you understanding this? The answer in this case would be 6000 joules. Okay, so this is your answer. Okay, I hope everybody was able to calculate this. It was a very simple question. Okay, how many of you were able to do that? Write it down in the comment section, chat box. Okay, okay, chalo. You have one more question now. You have 1 minute to solve this question. The question is, the device which converts mechanical energy into electrical energy which runs our microwave oven is. Half time is over. For this question, kindly please write down your answers, whatever you feel like, in the chat box. Just write down your answers in the chat box and I will check whether they are really correct or not. Just write it down there. Okay, so your time is up. Your time is up. Let us see what is the answer. The answer for this question is going to be alternator. Alternator. I have already told you, alternator is the device which converts mechanical energy into electrical energy. Before some time only we had covered that, right? I think in some of the conversion parts, alternators. This one, see, we had already covered that in the previous question, that alternators basically convert mechanical energy into electrical energy. So that is exactly what was asked in the question, that which of the following devices can convert mechanical energy into electrical energy. So out of these, who is converting? It is alternator. It's the alternator. Are you understanding this? Okay, so let us just see what are the conversions. Electric motor, it converts electricity to it converts electric energy or electricity into mechanical energy, that is moving parts, mechanical energy. What about alternator? That is the reverse position. It converts mechanical energy into electrical energy. What about turbines? See, turbines are just the moving parts. So basically they are connected to generators. So as such, they are just moving and they are connected to generators, and which generally generate electricity. But turbines are just the moving parts. They help in the conversion of which form to which form? They generally help in the conversion of, yes, basically the power is converted from potential energy to kinetic and then to electricity. And what about this one, the electric heater? It converts electricity, that is electrical energy, to, yes, it converts electricity to which energy? Heat energy. That is so true. That is so true. Okay. Now let us go for the next question. You have 1 minute to answer this question. A microphone converts what into what? Okay, it's a very simple question. Microphone converts dash into dash energy. You have 1 minute to answer this question. Just think over it and write it down in the comment section. It is so simple. Microphone converts what energy, which energy to which energy. So simple. Questions cannot be more simpler than this. Your half time is over. Write down your answers in the chat box. Be fast. Be fast and fast and fast. Is almost about to get over. Kindly think over the question and give me the answer. Microphone converts which energy to which energy? Okay, so your time is up. Answer for this question is going to be, see, microphone is nothing but in which you speak, right? And that signal, suppose let's say whatever you are speaking or what I am speaking, suppose let's say I have a mic in front of me. So my sound energy is getting converted to what? The microphone is converting into electrical signals. It is carrying my voice through the wires. So what I can say is, basically my sound energy is getting converted to what? Electrical energy, and which is being carried by wire. So you have to always remember, microphone converts which energy to which energy? Sound to electric. See, there is a lot of confusion between microphone and sound. Let me just give you a simple logic. So speakers and microphone, there are two things. Microphone, it converts sound energy to electrical energy. Are you understanding this? It converts sound energy to electrical energy. And what about speakers? Speakers like your laptop might be having speakers, or your desktop might be having speakers, our mobile have speakers. What they do, you are able to listen to sounds, right, with the help of speakers. So can I just say they are converting electrical energy to sound energy. Are you understanding this? So that is completely reverse of what we have regarding microphones. So in case of microphones, it is converting sound energy to electrical energy, and speakers is completely reverse to what is happening in the microphones. Sound energy is getting converted to electrical in microphones, and in speakers electrical energy is getting converted to sound energy. Are you understanding this? That is what exactly is the difference between microphone and speakers. It is the reverse position what we have. Okay. Sure. Now you have 1 minute to answer this question. A very simple one. Calculate the answer and give me the, suppose let's say, do the calculations as per the formula and give me the answers in the chat box. No options will be given for this. These are subjective based question. It's a subjective based question, so you just have to give me the answer. Calculate and give me the answer. A trolley is pushed along a road with a force of 400 Newton through a distance of 60 meters in 1 minute. Calculate the power developed. Okay, it's a very simple question. A trolley is pushed along a road with a force of 400 Newton through a distance of 60 meters in 1 minute. Calculate the power developed. Okay, your time is about to get over. Kindly complete it. Give me the answers in the chat box. Be fast. Use your pens on your notebooks. Do not do it orally. Try to calculate as per the, suppose let us say, numerical on your notebook. Okay, so your time is up. Let me tell you what is the answer. See, they are asking us that there is a trolley and it was being pushed along the road with a force of 400 newtons. 400 Newton force is being applied. So you can just write those details. Force is 400 newtons here. Now they are saying the distance covered was 60 meters. So either it is S, right? The displacement in this case is 60 meters. What about time? Time given here is 1 minute. But as you know, it has to be converted to second. So 60 seconds. Okay, and they are asking us to calculate power. Okay, let us just see if we can calculate power. Now for our formula, power is either work by time or power is either energy by time, right? But in our case, force has been given. Now according to us, force comes into play only if we are talking about work. So instead of using this formula, we are going to use this formula, that is power is equal to work by time, because only work has force, right? Work can be said as force into displacement, right? I can write down in place of work, I can write down force into displacement. Now below that the time will remain same. The time, suppose let's say the element will remain same. Now put the values in the formula. P is equal to, what is the value of F? That is 400. What is the value of S? That is 60. What is the value of time? That is again 60. So you can just cancel them out. So power will be 400. 400 and the unit would be watt. That's it. Are you understanding how this question has been done? So the answer for this question is going to be 400 watt. I hope everybody has got the same answer. It was a very simple calculation. Everything was given in the question. You just had to put it in the formula. That's it. Okay. So I hope everybody has enjoyed and has been able to give, let's say, proper answers. And do remember, students, we are going to have lots of Menti quizzes now, like on daily basis. So Menti quiz of today will be organized in the evening. I hope everybody will be, suppose let's say, attending this particular quiz. So I will post up the links in the, suppose let's say, afternoon or so. So kindly prepare the topic accordingly. I will let you know even the topic. But according to that, a Menti quiz will be taken. As I have already told you how to participate in Menti quizzes. So that will be organized in the evening. Kindly attend them. Chalo then. Have a nice day. We'll be closing the session now and we'll meet in the evening. Chalo. So thank you so much. Bye bye. Have a nice day.